All right, ladies and gentlemen, we're finally at the place where we can start talking about what an antiderivative is conceptually. Now that we know that it just undoes a derivative by its blatant name, we can actually start talking about what it actually does in terms of the theory and why it turns out to just be giant net change. All right, so let's take a look at it. Okay, so recall this is a couple things that you should have got out of calculus. This is the whole point of calculus. The whole point of calculus is to study rates of change, which is how fast. You knew that that's derivatives, okay? But then what's the other topic? The topic is net change, which is just overall how much change happened from point A to point B. Well, that could be like you started your career when you were 20. At 55, which is 25 years, how much did you grow by? Those kind of questions. Well, that is what integrals or antiderivatives answer. Okay, it's those bigger questions of just like boom to boom, how much is there? Okay, and we'll talk about what this means picture-wise and how it can look via graph-wise, okay, and what we're actually looking at. Because, you know, if derivatives are slopes, there's got to be some connection with antiderivatives on the graph as well. We'll talk about those. All right, so I want you to get an idea of this, okay? And it says, example is, and let's read the problem. At your job, your job pays, and let's say you get paid a flat rate, okay? That is, so what is the net change of your job excuse me, if you work 8 hours, okay? So it makes blatant sense, okay? It makes blatant sense. Why does it make blatant sense? Well, you worked 10 hours. Whoops. Go back one. There we go. What's the net change? And what's the net change? The money that you made, all right? Well, let's see here. Well, that's just going to be 10 hours times 8, right? So $10 per hour. So the rate times the number, the quantity, if you will, right? And that gives you the actual net change. You could also look at this as you just worked a full 8-hour shift. So I'm going to graph this just to give you some intuition. This is 0, this is 8, and they give you a flat rate of pay. So this is the dollar. So this is your rate of pay. So this is the way you could think about it. And this is the time. So this is dollars per time. So this is $10. So automatically you start to gain this intuition that, well, let's see here. If I were to take the rate, the amount of time that I worked, I don't know, what does that say? My goodness, let me write this a little bit. The amount of time, which is $10 per hour. So that's where that 10 came from. And then I worked it for 8 hours. You would expect, well, you'd have $80. But where would that come from on our picture? Well, what did we do? We measured, we multiplied 10 times 8. Well, 10 was here, 8 is here, so the 80 is actually the area underneath that curve. That's actually pretty interesting, isn't it? So that's our first piece of like kind of looking at how net change affects us and where the antiderivative will come into play, is because net change is the area under the curve. Okay, so let's take a moment. Let's look at this guy. Well, let's just change our job for a little bit. What if we got another job, right? Because we were like, oh, the first job just doesn't pay us enough, and that kind of thing. Well, what this means is that we could now look at. We can now look at the same day. Oh, it got black. Black's the wrong color to use on this thing. Okay, so now we have got 8 hours for the first 5 hours. So for the first 5 hours, we work in $8 per hour. Okay, and then $20 an hour anytime after that. And let's just say we work a 12-hour shift, just to make sure. So we work another 12 hours. Okay. Okay, and the other one you get paid $20 an hour, which is beautiful if you guys do it. Well, I want you to think about how you would calculate your money in your pocket, right? You would say I worked $8 per hour times 5 hours, right? Which gives you, and then you would add that to the dollars you got paid per hour times, and let's say we worked a 12-hour day, so that'd be the other 7 hours, and those would go, right? So this ended up giving you $40. I'm trying to emphasize on the units so you can just see that I'm not making things up. I always believed when I learned calculus or when I learned math that the units were just made up. I feel like that people just threw things together. But it really is because things cancel out, so it's dollars per hour, the hours go, and that leaves you a total of $210 you should end up with. Right, so this is kind of the cool thing. The units do matter. All right, so let me get back to my picture over here. And I drew the dollar per hour here. So So the rate is on the y and time is on the x. All right, but check this out. So for the first 5 hours, you worked here. So what is the area in that space? Well, that's 40. Okay, so you'll notice we instead of working that, we're breaking it up a little bit. And then anytime after that, so that's this space. So you kind of see a step that happened here. We call it a step function. But this is only 140. And why? Because this is 7. This is 7, right? So that distance. So that's how we find areas of rectangles, right? So what we're doing is we're finding the net change over that entire 12-hour day. And in this case, we get a pretty accurate one. The net change in money you're going to have in your pocket is $210. Okay? Let's get even more specific. Okay? Suppose you get a new job with the following rates, and this is actually probably a good place to be. $5 for the first 2 hours, $12 for the next 3 hours, $20 for the next 4 hours, and $50 for any time after. I don't know how you'd have any time after because you probably are just dead tired. But let's just assume that we're going to look for the net change. What happens if you work 10 hours, okay? So if I were to write this out in big notation, the net change is what happens from time 0 to time 10. Well, time 0 ends up being 0 because we started off with no money in our pocket. We just got to figure out this. Well, how are we going to figure out that? Well, that's pretty easy, okay? And this is all the other problems, but this is how I want to start writing my answers. To figure out my total money, my total net change, I need to first figure out the money, let's call that job 1 plus job 2. Well, how many more jobs does this given person have? Plus job 3 and job 4 is $20 an hour. My goodness, this guy just works all day long. 5, 12, 20. 5, 12, 20, and then we need one more, so that's job 4, okay? Well, how do you calculate the job? Well, he worked $5 per hour for 2 hours, because maybe he couldn't find a job that'll pay him that entire time, right? $12 per hour for the next 3 hours, and then $20 per hour for the next 4 hours, and then $50 an hour for next time after that. But hold on a second here. How much time do you already total work? 4 and 3 more hours is 7, plus 2 more is 9, so he can only work 1 more hour. But is that $50 an hour? That's a pretty good rate of pay. It's probably worth almost this whole day. Okay, so what does this calculate out to be? Well, that's 10 plus 36 plus 80 plus 50. Okay, and if you were to add this all together, I think we end up with $176. Okay, so that's because you had different rates of pay for different blocks of time. Unlike the other job he had, where he had longer spurts of something he was working for. So one interval was a certain amount, and the other interval was a certain amount. Okay, but it was all on the same time of day. So if we were to graph this, right, 2 hours, and then the next 3 hours we'll put them at 5, and then the next 4 hours we'll put them at 9, and then that last hour, and then he got paid, let's see, $5. Here's the 10. 5 times 2 is 10. And then for the next 3 hours, he got paid $12. So from here to here, that's $12, right? So that's 12 times 3 is 36. Remember, we're not looking at getting that entire area piece. And then $20, and then $50. Man, too bad he couldn't have more at the time of that $50 mark, right? This ends up being only 4 here, so it's the base of that rectangle plus 80, and then finally the base of that rectangle is 1 times 50 is 50. So that 1 hour was worth almost, my goodness, it's insane. So we got 36, 10, 80, and 50, and that's where these numbers came from, and that gives a total of $176. $176 is what his net change was from going from 0 to 10. Okay, but it was adding those 4 pieces together to get that. Okay, these are all how we go about estimating things, right? But what if you've got an employer and instead their last job they say, you know what? We want to pay you according to this function. And why is this function so important is because this rate of pay function allows you to estimate or to get a bit of money at every moment of the day. So even when you're sleeping, you're still making money. Isn't that nice? You're increasing pay even as you're sleeping, or decreasing pay, depending. Okay, so what is the net change of your wealth in 4 hours? So I have taken the liberty of bringing a graph up that has it. Okay, so if you look at this guy, and I'm going to try to do it. It says over the first 4 hours. So I'm going to just jump at the first 4 hours. So that's 1, 2, 3, 4, right? And it says, what is the net change in the net change in the 4 hours? Well, the problem is even if I don't even know how to draw a rectangle in here, like how do you get an area of a curve that is not something we already have a formula for? Like what? How do we do that? So this is the next topic of discussion. Well, this is what someone said, just to make things really, really clear. Well, if that's a conundrum, like, because you gotta know, like, if we broke this into two pieces and we said, okay, let's let one base be 2 and other base be 4. Well, what's the height? Is that a height? Because then you leave out this stuff, right? Like, I don't know how you'd go about finding that, and we don't have a real big formula to find areas of curves. Like, what would we do? Like, we would still leave out this stuff and this stuff if we did that. So, what's really the solution? And that's really the big thing, okay? Well, the good news is that the solution is that we are going to break this guy up exactly what I started doing, okay? So check this out. I'm going to start by first trying to take this graph and I'm going to start chopping it up into little pieces. And this is kind of the idea. And there's this guy I'm going to mention in the next video that actually gave way to this. But he says, you know what, we can't get down to like the exact with your rate of paginating like this, but I can estimate it really, really good. And this is what he did. He said, you know what, I'm going to take this graph. Sorry guys, I flipped forward, flipped back. And this is what he did. He said, okay, we're going to do what's called a left-hand side estimation, okay? And this is what he said to do. Well, we're going to break, since we're going from 0 to 4, okay, this is 4. I'm going to break it into 2 even intervals. And the idea is if I can find the area underneath this, if I break it into 2 intervals, I can at least get some areas base times height. So he said, okay, well, because remember, it's just like what we were doing before, trying to figure out what's happening here. Okay, so this is what I'm going to do. I'm going to draw my rectangles. This is what I'm going to do. You see these 2 intervals? This is 2, this is 1. I'm going to make the tallest part of this. And then I'll drop it down over 2. So I'm going to find that area, and then I'm going to find the area over 4. Now, you're probably saying to yourself, well, I'm going to have more area underneath that, and why am I looking for area? Because remember, we already talked about the answer is the area under the curve, exactly. And how do I get that? I don't know. So I'm going to try to estimate it in 2-hour intervals, okay? So I'm going to do 2, right, because that's the base here, because I can't find the exact area under that curve. So we actually use this notation called L2, which means a left-hand estimation. So I use the height, so the base is 2, and then what's the height though? The height is going to be this side right here, the left-hand side. And what determines that? When I plug in 0. So PR of 0 plus the base again is 2. What's the height? Well, the height is this thing at 2. Right? So it's the left-hand side. So that's PR of 2. Okay? And those are going to give me the heights because why? Again, just to emphasize, I know there's a lot of stuff on the screen already, this point is the height of this rectangle. This point is the height of that rectangle, right? So you kind of see why I need to chase that down because the left hand's determine the height. If I want to do a right-hand side, I could in a bigger kind of way. So like the less ones I had. Okay, so now if I do this, all this is going to do is estimate. It's going to estimate the amount of money. Estimate the amount. Let's use words we know. Estimate the net change. After all, that's what we're doing. We're going from PR of 20, PR of 2 to PR of whatever to 4. To 4. Yeah, 0 to 4. So here we go. So this ends up being a good approximation to how much money I should be making. So if I plug in 0 in there, that's 25. And then if I plug in 2 in there, it gives me 16, but it's negative. I get 9. So it ends up giving me a total of, what is this? 92. $9.21? 21? No, 9. 21. Plug in 2. 4. Yeah, 21. My goodness. My goodness. I was like, what is going on here? My answer says 92. All right, so they're saying this shaded area in here. Let me change a pen on here to make sure you guys have it. I know this seems a little long because I'm getting repetitive on some of this, but bottom line is all we did was find the area of those rectangles, and those rectangles underneath them are the net change, and that's why I've been trying to draw the relationship the entire time. So that was the whole big point of this. All right, moving on. So what's the big point here? Second attempt, what we're going to try to do here is I'm going to take the same picture, right, that we have, okay, and what I'm going to do is in this time I'm going to try to cut it up into terms of 4 hours. So instead of the L2, I'm going to do an L4, okay, an L4, which means I want to do a left-hand height estimation or left-hand area estimation, right, of this curve. So if I transform this, this is what we end up with. Well, and this is a good thing, so I'm going to cut this 4, so this is the end of 4. I'm going to cut the 4 into 1, 2, 3 pieces. Okay, that means all my heights should be coming from the left-hand side. So that means that the length of these rectangles now aren't 2 anymore like they were on the last one, right? They're now going to be 1, right? We cut it up equally. So that'll be 1 is the base of this times the height. Well, the height is going to be determined by the left side going all the way up to the function. So I need to do PR of 0, which will give me that height. But check this out. Now, if you know the over area, that area right there, that's not too, doesn't seem too high of an estimation like the last problem. Like, you see, look at that. It's just a little bit, right? So we sort of see that when we increase the amount of slices, if you will, it seems to get, like, less full of error. Less error. It's more correct. Same thing here. This guy is like, yeah. So you notice it's not taking on as much. It's getting closer and closer and closer to being perfect. Same thing with this guy's height. Whoops. Same thing with this guy's height. Right? So we don't take on as much rough area. We take on a little bit more, but not that much more, right? We leave off a lot of the extra pieces that we had last time. So this is the base times height, right? The base of 1 times the height, which is PR of 0, plus 2, plus a base of 1 again, right? The base from here to here would be 1 times the left-hand side, which is PR of 1. And then we need to add this to 1. I ran out of space. I always do this. Plus 1 PR. We're plugging into that function of 2. And then plus 1 PR of 3. Okay, so now when we plug it in, where are we plugging into? Don't forget your function looks like this guy. That's PR of our rate of pay, right? That's what pay rate is, right? You plug in 0, you get 25. You plug in 1, you get 24. You plug in 2, you get 21. And you plug in 3, you get 16. Okay? So if you do this out, then you get 86. Now I want you to think about this. We went from just now, we were saying that we were getting paid. How much money? Go back a slide. $92. Well, and that's what we thought we were getting paid. But you notice that when we started looking at the rate of pay instead of a 2-hour interval, now it's a 1-hour interval. So let's start clocking it every 1 hour. I'm starting to realize that I'm getting paid $86. It's not as much, but it's more correct. The other one was an overestimation. This is a better overestimation because I still got some areas that are above this. But this is just, again, an estimation of what the area would be from 0 to 4. Because remember, the goal is to find the area, and this is the exact area, right, of 0 to 4 by it. But we're just doing the estimation because we don't know any other way to find the area. All right, moving along. All right, so now let's do it one more time, but this time attempt number 3. I'm going to try to cut this 4 up. Oh my goodness, into 8 pieces, okay? I'm going to try to not draw this because it's going to hurt me or hurt you or hurt us, just me. But I want you to imagine this. It cuts up into 8 pieces that are equal. And yes, I am not good at this. Oops, not that last one. All right, each one of these will be its own mini rectangle, if you can imagine. Right, so you kind of see that the heights of these rectangles are going to be generated. So it's a lot of exactness, but these little bits of area add up so well. So watch this. Now the height, the base of these rectangles are halves, right? Notice they're all halves. The heights are determined again by the left-hand side, so I'm going to have to start chopping these up. So the first one's 0. So let's see, we're doing a L8, okay? Actually, screw that. Let's do a right-hand side this time. I did a couple left-hand side ones. That means you take the area of the left-hand side, so this will be a half instead. And that, so in general, left-hand sides tend to give you overestimates. Right-hand sides tend to give you underestimates. And that the reason why we bounce back and forth is because we can say, okay, if the overestimate was, what was the overestimate? The last overestimate was, oh goodness, 86? Well then, where's the underestimate at? That's the big question. All right, let me get back to where I was at. So R8 ends up being a half is the base times PR of a half. Okay, so the pay rate of a half, right? So that half hour, and then it'll be a half base times height again of PR of 1. And you can tell I'm going to do this for quite a while, all the way till I get to 1/2 times the pay rate, but which one? The one that happens at 4. Notice we never really had that we never had 4 in any of the calculations before, what the pay rate was at 4 hours. So now this takes that into account. Now when you add all this up and you grind it all out, you get 74.50. So what does that tell us? The left-hand side was higher. The left and higher and larger than this. But then we did a right-hand side, and it seems like it's coming up, and it's coming towards a number. What else did we know what was like this? Well, it's when we were taking limits and we were approaching things. Isn't that something interesting? Like 74.5 was one direction. And now I'm going to give you a little bit of an idea. We're going to do a whole bunch of left-hand side ones. I want you to check this out. When you start with 2, we got $92. When we broke them into 4 rectangles, estimated it was $86. 8 of them ends up being 74.5. Okay. And then that really is the right-hand side, though. So this one disregard. Let's say I broke it up into even more rectangles. It should be even more precise, which it is. Now, you think, oh, am I probably going to stop at 80? Absolutely not. It goes to 79.66. That goes to $79.16. So you're like, oh, my God, $79.16. It's got to slow down. 79 must be it. No, it's still changing, right? So here's the point. If we keep chopping up these little rectangles and looking at the pay over an average interval, right, here to here, here to here, here to here, here to here, the only way I'm actually going to find the exact area if I know how much I'm getting paid at one moment. And so I can say at the moment, 1 o'clock, I know I'm getting paid exactly this much money. And that is what this thing is trying to do. So what is the exact amount I should take home? We'll talk about it more on the next video. Thanks a lot, guys.